Alright, so here we are. We are looking at people gaining weight during the holiday season. I love food. Standard deviation for the entire population is 2.1. We're going to construct a 98% confidence interval. So what does that mean? It's going to look something like this. We got to draw a picture. This area here is 0.98 in the middle. Now, one thing I noticed some people doing, and I'm not calling anybody out, but I do want you to understand it. I saw a lot of people going 0.02 and 0.02. You can't do that. If you do that, that's 0.02, 98, 0.02. That's 1.02. That's over 1. You can only have 1. It's got to be a total of 1. So what you got to do is take that 0.02 and divide it in half. That's where the alpha over 2 comes from. 0.01 and 0.01. Now, part B, you got to know the formula. The formula is, in case you've forgotten, here it is. X bar minus E is less than mu, which is less than X bar plus E, where E is equal to Z alpha over 2 times sigma over the square root of N. That's an E, by the way, and that's an equals. Okay.
E equals, that's a T?
No, that'd be a Z.
It's a Z.
Clearly.
Okay.
Here. Z. 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 All forms of that. All right. What's that?
Not very much better.
Clear. All right. Part C. Got to do a little bit of work. A little bit of work. So we got 8. What the hell we have? We have 8.4 minus. Oh, we never looked the values up. What were y'all thinking? Somebody looked up 0.01 on the chart. I think you got 2.33 and negative 2.33. And by saying I think you got that, I mean you should have gotten that. Some of you got 2.32, and you're thinking to yourself, oh, I was so close. Yeah. That's what the pilot said when he bombed the wrong people. I was so close. Just the wrong damn city. I was close. 2.33 is 0.0099. 2.32 is 0.0102. 0.0099 is closer, so we want to use that value. So 8.4 minus 2.33 times sigma, which is 2.1, over the square root of 49. Now in doing this, we can use our calculator. Well, we'll go back to it, type in the other side first. It is less than mu, which is less than 8.4 plus 2.33 times 2.1 over the square root of 49. Now, with that being said, we will go to our calculator super fast. And we're going to do 8.4 minus 2.33. One thing I saw some people doing on the test, and again, I'm not trying to call you out. I really want you to learn from the mistakes you made. Some people put this in parentheses. Okay? And that's not good. Because what happens is it screws up the order of operations for the actual formula. So there are no parentheses for this first piece. 8.4 minus 2.33 times 2.1 divided by square root of 49. Okay. Now, once you get that answer, you're going to want to do the other side. So second enter will bring you back the original equation. You can switch it to a plus sign, hit enter, and that should give you your desired results. So we're going to take a screenshot of that. We're going to come over here, and we're going to take that and we're going to paste it right there. Okay. And so what we see then is that this value is 7.70. 7.70 is less than mu, which is less than 9.1. Okay. All right, part D, how do we interpret? Somebody can do that for us, I hope. Anthony, go ahead.
If we continue taking samples of 49, we expect 98% of the sample means to fall between 7.70 and 9.1.
If we continue to take samples of size 49, we expect we expect 98% of the sample means to be between 7.70 and 9.10. Part E. What was your assumptions? Since n is greater than 30, the sample mean is normally distributed. Okay. Now, there's a lot of discussion yesterday and last night and even earlier today about how do we know if I'm using a z-score or a t-score? Because the other problem requires me to use a t-score, and how do I tell when I read it because I don't really ever know the difference? And the answer is, it comes down to this right here. Standard deviation for the population. If we know that, if sigma is known, then that's a z-score. If sigma is not known, then we have to use a t-score. Okay? Now, I will tell you that in most cases, when I do it for the test, most cases, not for homework, but for the test, generally speaking, you can also look at n. When n is bigger than 30, that's another telltale sign. If n is bigger than 30, that's another telltale sign. Okay?
Z-score.
That you have to use a z-score. Why? Look at the assumptions. Since n is greater than 30, the sample mean is normally distributed. Okay. All right. Now, this one's going to be a t-score because we don't know. We don't know the standard deviation of the population. So this is 95. Makes here on the outside 0.025. Degrees of freedom. Who's my degrees of freedom expert? Deanna. Degrees of freedom? It is n-1. It will always be n-1 for this class. So, looking up n-1 degrees of freedom. And in this case, we have a sample of size 16. So, degrees of freedom, Deanna, is 15. Looking up 15. 0.025 in one tail, 0.05 in two tail. What do you get? I'm sorry, I'll find it. You all just sit there. Okay, go ahead. What do you get?
2.131 negative.
2.131 confirmation.
Yep.
Here's what you find, Deanne. A lot of people give confirmation, but no one wants to give the answer to start with. All right, part B. Got another formula. The formula is x bar minus e is less than mu, which is less than x bar plus e. And e is equal to t alpha over 2 times s over the square root of n. Okay. Any questions on that?
What's S?
Standard deviation. Now, we got 118 minus 2.131 times 19 over the square root of 16. Plus 2.131. Alright, typing that in. 118 plus, or excuse me, minus 2.131 times 19 over the square root of 16. Yes, I know we could say it's just 4 and do that in our heads, but let's don't get crazy. Okay, 107.88 or 107.9 if you will. Second enter. Change the minus to a plus. 128.12. So 107.88. Let's just save this. And we'll get 107.88.
Why is that when that 118 it doesn't have any numbers after?
We'll get 107.9 is less than mu, which is less than 128.1.
I mean, why would we get the decimal at all?
You always get one decimal place more than they started with. So they didn't start with any, so you get one place further than that.
Sorry.
All right, I'm not going to interpret this except to tell you just verbally, if we continue to take samples of size 16, we expect 95% of the sample means to be between 107.19 and 128.1. Okay. Your assumptions in this case are what?
The population is normally distributed and sigma
Population is normally distributed, and sigma
is
is unknown. And that says unknown in case you can't read it.